general physical properties of alcohols. The lower members are colorless, volatile liquids. The lower members are completely miscible with water. So why it is miscible with water? Because mainly it forms hydrogen bonding with water. So we can see here in this picture, the oxygen of ethanol is forming a hydrogen bond with hydrogen of water. So this weak interaction between molecule of alcohol and the molecule of water will result in the miscibility of the alcohols with water. So solubility decreases with increase in the molecular weight. So lower members will have a better interaction, a better hydrogen bonding with water when compared with that of the higher members. So we can even consider about the boiling point. In case of alcohols, the boiling points are higher than respective alkanes. Again, the same reason, that is, the alcohols will form hydrogen bonding within themselves. So what happens here is higher temperature is required in order to break this hydrogen bonds. Or in other words, higher energy is required to separate the alcohol molecules. So because of this, the boiling points of alcohols are higher when compared to that of respective alkanes. Next is reaction of alcohols. So acidic nature. So we know that whenever we add a metal to an acidic solution, it will release hydrogen gas. So the same thing happens with respect to alcohols. So we take alcohol and add any reactive metal, it will release hydrogen gas. So we can see this example. Ethanol, when it reacts with sodium metal, it will give rise to sodium ethoxide, the liberation of hydrogen gas. Next is esterification. Esterification reaction is one of the most simplest type of reaction. So we know that esters are formed by the reaction of carboxylic acids and alcohols in the presence of any strong acid as a catalyst. So here we can see the carboxylic acid and alcohol. The presence of catalyst like concentrated sulfuric acid will give respective esters. So here we take acetic acid, ethanol, the presence of concentrated H2SO4 as a catalyst, we get respective ester, that is ethyl acetate. Next is oxidation of alcohols with KMnO4. So acidified KMnO4 acts as a very good oxidizing agent. So we know that alcohols will get converted to aldehydes or ketones on oxidation, which will get further oxidized to respective acids. So one thing we have to remember, the primary alcohols will get converted to aldehydes, and these aldehydes will get converted to acids. Whereas if you take secondary or tertiary alcohols, on oxidation they will give respective ketones. Again, on oxidation of these ketones, we get respective acids, that is carboxylic acids. So here, this test can be used to differentiate alcohols, that is, in order to identify whether the alcohol is a primary alcohol, secondary alcohol, or a tertiary alcohol. So primary alcohol on oxidation will give the acid having same number of carbon atoms as the alcohol which we have taken. So here we can see RCH2OH. In the product also there is R and 1 carbon. So there is no loss in the number of carbon atoms on oxidation of primary alcohol. Moving on to secondary alcohol. Suppose we take, here you can consider there are 3 carbon atoms in the alcohol which we have taken. But if you observe the product, there are only 2 carbon atoms. So here there is a loss of 1 carbon atom, or the acid that is formed has 1 carbon less than the alcohol which we have taken. So this test can be used. Just if we analyze the product, we can identify that the alcohol which we have taken in the beginning, the secondary alcohol. Next, tertiary alcohol Again, it will undergo oxidation in the presence of acidified potassium permanganate, and the product will have 2 carbon atoms less than the alcohol which we have taken. So again, we can count here. There are 3 carbon atoms plus 1, 4 carbon atoms in the alcohol which we have taken. But in the product, we have only 2 carbon atoms. So there are 2 carbon atoms less than the alcohol which we have taken. So here, by this test, we can identify which are primary, which are secondary, and which are tertiary alcohols by the analysis of the products that we obtain after the reaction. So just by visual observation, whether we can identify which is a primary alcohol, which is a secondary, and which is a tertiary alcohol. So we have a solution to this, which is called as Lucas reagent test. So Lucas test, here we make use of Lucas reagent, which is nothing but anhydrous zinc chloride, which is present in concentrated HCl. So this will give a visual observation so that we can identify whether the alcohol which we have taken is a primary, secondary, or a tertiary alcohol without actually going into detail of the analysis of the structure of the molecule. So the test is very simple. So we take alcohol and we know that the Lucas reagent has HCl, concentrated HCl. So we can observe that the product that is formed here is RCl, which is nothing but alkyl chloride. So based on the formation of alkyl chloride, we can identify whether the alcohol which we have taken is the primary, secondary, or tertiary alcohol. What is special about this alkyl chloride? The alkyl chloride, how fast this alkyl chloride is formed from the respective alcohol will let you know which type of alcohol is the alcohol which we have taken. So let us move on to see how we can actually visualize the results. So tertiary alcohols will give the turbidity very fast. So what actually happens here is the alkyl chloride which is formed, it is insoluble in HCl. So you can see the turbidity that is formed during this reaction. So if the turbidity is formed immediately, we can say that the alcohol which you have taken is tertiary alcohol. Suppose if the turbidity occurs, but after some time, that is within 5 minutes, then we can say that the alcohol which we have taken is a secondary alcohol. Same way, if the turbidity is not formed at all at room temperature, only after heating, if you observe this turbidity, then we can say that the sample of alcohol which we have taken is primary alcohol. So this just gives results very soon, and also we can see this, we can visualize the results very easily in order to identify the type of alcohol. So why this happens? Why the tertiary alcohol gives turbidity immediately? Why the secondary alcohol takes some time, whereas the primary alcohol does not give turbidity at room temperature? All this is attributed due to the formation of carbocation. So we know that the tertiary carbocation, the tertiary alcohol, whatever we can say here, if this bond is broken, we know that this carbon will get a positive charge, or in other words, we get a carbocation. So the carbocation that is formed here is tertiary carbocation. Tertiary carbocation is stabilized by 3 R groups. So we know that the R groups or the alkyl groups are electron releasing in nature, or they have plus I effect. So what happens here is, due to the 3 electron releasing alkyl group, this carbocation is more stable, or it is easily formed during this reaction. So because of this, the tertiary carbocation is more easily formed, and hence tertiary alkyl chloride is easily formed. Because of this easy formation of tertiary carbocation. So the turbidity is observed immediately. So what about the secondary carbocation? We know that in secondary carbocation, there are two R groups, two electron releasing R groups. The stability is little less than the tertiary carbocation. So because of this, the ease of the formation of this secondary carbocation is not as high as that for tertiary carbocation. So here the turbidity occurs after some time. Same way, in the primary alcohol, the primary carbocation that we can see here, it is stabilized by only one R group or one electron releasing R group. So the stability is much lesser when compared to that of secondary as well as tertiary carbocation. So here the ease of formation of this primary carbocation is still very less when compared to that of secondary and tertiary alcohols or secondary and tertiary carbocations. So because of this, the turbidity is not observed at room temperature. To make this, to enable the formation of this primary carbocation, we need to give some energy, or we have to increase the temperature so that this primary carbocation is formed, which will give rise to respective alkyl chloride. So in this video, I have explained the different methods of preparation of alcohols, different examples for the different types of alcohols, classification of alcohols based on the type of groups which are attached to OH groups or primary, secondary and tertiary alcohols. I have also explained about the properties of alcohols, both physical properties as well as chemical properties. And also I have explained the tests which can help us in identifying which is a primary, secondary and tertiary alcohol. I hope you have liked the video. You've got enough information about the properties and reactions of alcohols. Thank you for watching this video.